If someone walked up to you right now and asked you, what is the absolute most powerful way to build a local dashboard in the year 2026? What would you guess?
I mean, you'd probably think of something heavy, right? Something really complex.
Right, exactly. Like a
Yeah.
sophisticated programming language or some massive framework. You'd probably guess, I don't know, Swift for Mac or maybe C# for Windows,
Mm.
or perhaps a massive bundled framework like Electron.
Oh, definitely Electron. That's the go-to thought.
Yeah, you'd expect something that comes with this bulky installer, a progress bar, a really lengthy license agreement that nobody reads, and, a shiny permanent app logo sitting right there in your dock.
And that mental model is just deeply ingrained in all of us. It is the default expectation for what we consider, quote unquote, real
Yeah.
software.
Yeah.
And it has totally dictated how developers and users have interacted with their machines for, well, the better part of 3 decades.
But here is the reveal, and it is genuinely surprising. The most capable local application you can build today isn't any of those things. It is just a single HTML file.
Just one file.
Just one.
Hello.
We aren't talking about a website that you navigate to via URL, and we aren't talking about some cloud-based web app that needs a constant internet connection to function.
Right. This is completely different.
Exactly. We're talking about a completely local dashboard. One single sub-megabyte file that you double-click, and it runs with the entire weight and computational power of the modern browser behind it.
It sounds counterintuitive at first. I mean, because we are conditioned to think of a single HTML file as a static document, like maybe a syllabus or a really basic landing page.
Yeah.
But what we are actually looking at is a massive leap forward in application architecture.
Welcome to today's deep dive. Our mission is to explore how the browser silently, and honestly almost entirely unnoticed, killed the traditional desktop app.
It really did sneak up on us.
It did. And we are pulling all of our insights today from a really sharp, paradigm-shifting article by technology writer and software engineer Aaron Lowe's. It was published over on tech-reader.blog, and the piece is aptly titled, "The Death of the Desktop App You Just Haven't Noticed Yet." Okay, let's unpack this.
Yeah, so to fully grasp the magnitude of this shift, we have to recognize that we aren't just talking about, web technologies getting a little bit faster or CSS getting slightly more polished.
Right.
This is a fundamental reimagining of what a software runtime actually is. For the entire history of personal computing, the operating system was the primary runtime environment for our daily tools.
Oh, sure. Windows, Mac, Linux.
Exactly. But what the author argues is that we are shifting that immense responsibility entirely away from the OS, and we're just handing it over to the browser.
But before we get into the exact mechanics of how a single HTML file actually pulls off this incredible heist, we really need to look at the victim. We have to examine why the traditional desktop app model started to crack under its own weight in the first place.
And it was a long time coming.
Oh, absolutely. Because for a very long time, if you said desktop app, you were signaling power. You meant native APIs, full unbridled disk access, that permanent icon. It basically meant you were doing serious heavy-duty work.
But the pursuit of that native power is exactly what led to the current bloated state of desktop software. I mean, fast forward to 2026, and the reality of building, maintaining, and distributing a native desktop app has just become defined by absolute friction.
Total friction.
The source article points out that developers are forced to deal with these incredibly fragile installer pipelines. You have OS-specific frameworks that just inevitably drift apart year after year.
And that drift is something you, as a user, feel constantly, even if you don't really know the technical terms for it. It's why a tool you love on your Mac suddenly looks and behaves completely differently when you have to install it on your work Windows machine. Or worse, you experience what developers call dependency sprawl. You download an application, but it flat out refuses to open because your specific machine is missing some, obscure Visual C++ library, or a random framework that the developer just assumed you already had installed.
And then you factor in the distribution nightmare. To release a native application today, you have to navigate these complex code signing and notarization rituals.
Oh, the notarization.
Right. You have to cryptographically prove to Apple or Microsoft that you aren't a malicious actor just to get your software to run without throwing terrifying red flags to the user. The gatekeeping from these distribution channels basically dictates how and when you can release your own software.
And the update systems for these native apps break constantly, which just leaves users stranded on old versions.
Yeah.
And from the user's perspective, think about the very first interaction you have with a carefully crafted, desktop app you just downloaded. It is almost always an intimidating warning dialogue from your operating system, essentially screaming at you. Are you absolutely sure you want to run this potentially dangerous file from the internet?
It's exhausting.
It is. Building a traditional desktop app today, it's like buying a massive, heavy-duty commercial pickup truck, the kind with 18 wheels and a smokestack, just to carry your weekly groceries home from the supermarket. The desktop app didn't necessarily die because it stopped working. It just became way too heavy, too complicated, and honestly too expensive for the actual everyday problems most people need to solve.
What's fascinating here is the deep irony of the situation.
How so?
Well, the entire quest for deeper integration and more direct control over the operating system actually ended up alienating developers and frustrating users. The friction itself became the defining feature of the native app experience. And that massive vacuum, that total exhaustion with the heavy gate-kept process, created the perfect environment for something absolutely nobody expected to take over: the browser tab.
Which brings us to the elegant solution that rushed in to fill that void: the single-file local dashboard. And the article makes a very crucial distinction here that we really need to emphasize for you. This is not a web page.
Great, that's key.
When we think of a web page, we imagine a document hosted on a server in Virginia that we request access to. But this HTML file is a self-contained application runtime. It just happens to use the browser as its engine.
And the user experience of this local dashboard model completely flips the native script. I mean, it is frictionless by design. You have this single file on your desktop, you double-click it, it opens instantly in a browser tab.
Instantly.
There is no installer wizard asking you to click next 5 times. There's no asking where you want to save the application files in your system registry. And thankfully, no license agreements to scroll past before you can actually use the tool you just downloaded.
And it runs totally offline. This single file can read and write to your local disk, store gigabytes of structured data, and even sync your work across different tabs without ever touching a network or a cloud server.
Which is huge for privacy.
Massive. Plus, it runs identically, and I mean perfectly identically, on Windows, macOS, Linux, and Chrome OS. Zero install. Zero friction updates, because when there's a new version, you just delete the old HTML file and replace it with the new one. No DLL hell. No package managers failing to resolve dependencies. Just the file.
And this relies heavily on the reality that Chromium-based browsers have essentially become the universal, standardized computing platform for the globe. The environment is identical whether you are on a $1,000 MacBook or a $200 Chromebook.
Okay, but, and I have to push back here a little, a single HTML file processing massive data sets without crashing sounds impossible based on how browsers used to work. Wait, a single HTML file, under a megabyte, if it's that small, how is it doing heavy analytical lifting without secretly relying on some massive cloud server farm? I mean, I remember when having 5 tabs open would freeze a laptop entirely. What fundamentally changed under the hood to make that level of compute power possible locally?
That skepticism is totally valid, but it really stems from an outdated mental model. We were all trained to think of the browser as a somewhat fragile window used strictly to look at text and images hosted far away.
Right.
But the reality in 2026 is that the browser has evolved into a highly optimized, extremely high-performance sandbox. The web platform didn't just slowly iterate until it was good enough to fake a desktop app. It evolved to become objectively superior for this entire class of local-first tools by quietly amassing an absolute arsenal of modern application programming interfaces, or APIs.
Let's break down that arsenal, because this is really the core of how the single file pulls this off. We're talking about capabilities that used to be strictly the domain of low-level native code. First off, the File System Access API. Historically, a browser couldn't touch your hard drive.
No, it was completely walled off.
Exactly. But this API allows the HTML file to directly read and write to specific folders.
And the mechanism behind that is brilliant. Instead of giving the application blanket access to your entire hard drive, which is what a native app usually wants, the File System Access API relies on explicit token exchange.
Okay, what does that mean in practice?
So the user physically selects a folder via a native prompt, and the browser grants the HTML file a secure, temporary token to read and write only within that specific boundary. You get the power of native file manipulation without the systemic risk of an application secretly scanning your entire documents folder in the background.
That's incredibly smart. Then you have data storage. We aren't talking about tiny little tracking cookies anymore. You have IndexedDB.
Right. IndexedDB is essentially a robust, transactional, local database that lives right inside your browser profile. It allows this single HTML file to structure, index, and query gigabytes of data locally. It acts almost like a built-in hard drive partition dedicated solely to your local web applications. Your data stays on your machine, instantly accessible without a network round trip.
Which naturally leads to the problem of memory. If I try to load a massive data set into an application, I don't want it to freeze my computer. This is where the Streams API comes in. The article highlights this as a game changer for analytical tools.
Oh, the Streams API is incredible. The best way to understand it is to think of how we process water.
Okay.
The old way of processing data in a browser was like trying to fill a massive bucket all at once. If the data set was larger than your available memory, well, the bucket overflowed and the browser tab just crashed.
We've all seen that aw snap page.
Exactly. But the Streams API changes that architecture entirely. It processes data like water flowing through a hose. The HTML file can take a terabyte-scale data set, pull it in chunk by chunk, process each piece, and discard it before pulling the next. It allows a lightweight browser tab to process infinitely large files without ever causing a memory blowout.
That is incredibly clever. But even with Streams, heavy computation can still make a user interface feel sluggish, right? If the app is busy crunching numbers, the buttons stop responding. That's where web workers and WebAssembly enter the picture. This brings true multi-threaded computation to the browser, right?
Exactly the right concept. Historically, JavaScript, which is the language of the browser, was single-threaded.
Meaning it could only do one thing at a time.
Right. If it was doing heavy math, it couldn't also register your mouse clicks. Think of web workers like hiring a dedicated sous chef for a kitchen. Instead of the head chef trying to frantically chop heavy, dense vegetables while simultaneously managing the delicate sauces on the stove, which causes the whole kitchen to back up and freeze, the head chef hands the heavy chopping off to the sous chef in the back room.
I love that analogy.
Yeah, so the web worker crunches the massive data in the background, keeping the main interface, the head chef, completely buttery smooth and responsive to the user.
And if you have multiple tabs of this dashboard open, you obviously don't want them stepping on each other's toes or constantly trying to read the same file at the same time. The author mentions the Broadcast Channel API for this.
Yes. The Broadcast Channel API acts like a localized radio frequency that only your specific application tabs can tune into. If you update a chart in one tab, it broadcasts that change over this internal frequency, and the other tabs update instantly. There is no need to bounce a signal off a remote cloud server and back down to your machine. It is instant, peer-to-peer synchronization entirely contained within your own computer's memory.
And tying it all together, guaranteeing that this entire setup works flawlessly even if you are on an airplane with no Wi-Fi, are service workers.
Think of a service worker as a very smart traffic cop sitting between your HTML file and the internet. If you lose your connection and the application tries to request a resource, the traffic cop intercepts that request and seamlessly reroutes it to a local cache on your hard drive. The application never even realizes it's offline.
When you stack all of these together, explicit file access, gigabyte database storage, stream processing, multi-threading with sous chefs in the background, local radio broadcasts for syncing, and a traffic cop for offline execution, you suddenly have an environment with a performance ceiling that rivals almost anything you'd build natively.
Oh, absolutely.
Here's where it gets really interesting, though. You look at all that raw power, and historically in computing, power means danger. The browser was always seen as this massive vulnerability point. You click the wrong link, and your computer's infected. But the article points out a fascinating paradox. Because the browser evolved in the most hostile environment imaginable, the open internet, it was forced to develop a security model far superior to the native desktop.
The browser assumes everything it runs is actively malicious.
Right.
That is its baseline posture. Therefore, it enforces explicit user consent boundaries for every single action.
Yes. If you download a traditional native application and install it, it generally has free reign. It can quietly look through your photos, read your documents, or monitor your network traffic. But if a local HTML dashboard wants to read a folder, the browser pauses everything. It throws up a secure, unspoofable prompt and asks you directly, do you want to grant this specific file access to this specific folder? It forces consent at the point of action.
You are getting the raw computational power of the machine, but you are getting it wrapped in strict, standardized guardrails. That is a combination that traditional native runtimes rarely deliver cleanly. If we connect this to the bigger picture, it becomes clear that building a local dashboard as a single HTML file is not a workaround. We aren't hacking a web page to pretend to be an app.
It's intentional.
Very much so. This is a purpose-built, standardized local application stack. The browser has transitioned from being a mere tool to access the network to being the most stable, secure, and durable application runtime in all of computing.
Let's turn to the other side of the coin for a moment, because the HTML file hasn't conquered absolutely everything just yet. The source material is very clear about the caveats. There are still a few remaining strongholds where the traditional native app clings to life.
Sure, there are specific use cases where the native operating system still heavily favors its own native binaries. For instance, if you want an application to run silently in the background the moment you boot your computer up, a native app can register itself to launch at startup seamlessly.
And there are those deep system integrations, living permanently in the menu bar on a Mac or the system tray on Windows, or having the ability to access the entire file system continuously without prompting the user to select specific folders every time the cache clears.
But the author categorizes these not as core software capabilities, but as integration conveniences. The argument is that for a tool you open intentionally, use intensely for a specific analytical task, and then close, which is what most local dashboards are, those deep system integrations simply don't matter to the core function of the tool.
I think we need to linger on this because I genuinely disagree that these are just minor conveniences. I mean, if you were building a tool that you want someone to use every single day, doesn't that psychological weight matter? Having that little custom icon in the menu bar, or not having to deal with a browser asking for permission to read a folder, well, read a folder every single time. That is what makes an application feel pro. If I have to open a browser tab to use your software, it feels transient. It feels a bit like a toy, regardless of how much multi-threading it's doing in the background. Doesn't the native app still hold the high ground on perceived professional quality?
The psychological barrier you are describing is very real. Users do associate permanence with professionalism. However, look at the actual trajectory of the software industry over the last 5 years. Tools like Figma for design or VS Code for development completely dismantled that psychological barrier. They prove that if the tool is powerful enough and the user experience is frictionless enough, professionals will happily do their most critical work inside a web rendering engine.
I suppose that's true.
And this raises an important question based on the trajectory of web standards. What happens the exact moment the web platform inevitably gains a standardized run at startup permission, or a standardized API for a menu bar widget?
Oh, wow.
Right. The web platform is a relentless tide. It constantly absorbs native features, standardizes them, and puts them behind secure consent boundaries. Once those final few integration APIs are formalized, the very last psychological and technical advantage of the native application disappears entirely.
It really is just a one-way street. The browser just keeps absorbing capabilities, slowly eroding every single reason a developer might have to build outside of it. Because once the capability is there, why would you choose to take on the massive burden of installers, code signing, and platform drift?
You wouldn't. When you look at the architectural advantages you inherit by building this way, the zero install user experience, the absolute lack of dependency sprawl, the cross-platform parity, it becomes almost impossible to justify doing it the old way. Your users never have to worry about updating frameworks. Everything runs deterministically exactly the same way on every single machine.
So what does this all mean? If you are sitting down today to build a new tool, let's say this tool needs to be local first. It is going to handle heavy amounts of structured data. It requires strict privacy, so you absolutely do not want data leaving the local machine. It needs to work offline, and it needs to put the user entirely in control of their files. According to the insights in this piece, you shouldn't be booting up Xcode. You shouldn't be building an Electron bundle that forces your user to download an entire redundant, heavy browser engine just to run your one app. You certainly shouldn't be building a traditional native app, and you shouldn't be building a cloud-dependent software-as-a-service product.
No, the logical conclusion of all this technical evolution is that you should be building a single-file HTML dashboard.
The ultimate takeaway here is a profound shift in identity for both the people who make software and the people who use it. You aren't just building web pages anymore. You are building native quality applications that run everywhere, install nowhere, and update by doing nothing more than replacing a single file that is under a megabyte in size. The traditional desktop app didn't lose the war because it somehow got worse over time. It lost the war because the browser simply got so remarkably, undeniably good.
It is a quiet revolution happening right under our noses. But as we wrap up this deep dive, I want to leave you with a final thought to mull over, one that extends the author's premise out to its natural conclusion. If a single sub-megabyte HTML file running inside a sandboxed browser tab can now seamlessly, powerfully, and securely replace complex, heavy desktop software, what does that mean for the future of the operating system itself?
That's a huge question.
It is. If the browser has truly become the ultimate universal runtime for all of our daily tools and workflows, is the operating system eventually just going to become a glorified bootloader? Is Windows or Mac OS destined to be nothing more than the underlying firmware whose only real meaningful job is to launch your browser?
Wow. That is a wild thought to leave on. Imagine dropping that massive heavy-duty commercial pickup truck off at the junkyard. Not because you stopped driving, but because you finally realized you could just carry everything you ever needed right in your pocket. Thank you for joining us on this deep dive. Keep questioning the software you interact with every day. Keep looking under the hood to see how things actually work, and we'll catch you on the next one.